Alright, time for another DraftPhysics.com, debatephysics.com, also over and over. It is just surprising in, overview and contemplating the circumstance that no physicist ever thought to go back to these ideas, these established axioms of physics and say, well, is that exactly right? Or is that complete? Or does that really work? And, it's in the context of, characters like Einstein who, were still revered. But there was a great deal of controversy, frankly, and uh, I don't know, hurt feelings, you could even argue, in terms of this idea that he wasn't allowed to complain that quantum mechanics seemed a bit mushy and, and silly, even. Um, and I guess to some extent you can understand the blowback from that is that everybody gets defensive and insulting and all that kind of crap. But the fact that yes, even in that context, they still are so confident that this story they tell is somehow the truth, and there's some sort of big giant pile of evidence, and there really isn't. They just say GPS, F equals ma, some sort of crap, and it's really not, all that. And again, I keep going back to the Eddington experiment. It's such a clear example that it's this one, particular experiment that does something none of the other experiments are doing, because you're actually visually seeing, okay, this effect of bending light, and you have some guarantee because it is an actual image that there's no shenanigans. There's no possibility of it being some kind of defect from fog and scatter and all of that kind of crap. And there's just uh, no passion for this idea that, well, why don't we do that one from space? I mean, there's this 400 times better resolution. You don't need an eclipse. It only takes 5 minutes. I mean, and there's just nothing saying, why haven't we done that experiment hundreds of times? I mean, just trying it for all different kinds of ways. Use Jupiter, do different things. And there's just no evidence they even thought of it. No, come on, it's just impossible to call that honest science. That this isn't, this isn't a scientific investigation. This is a inquisition. Okay, these are religious people, and they're just practicing their authoritarian, dogmatic. You must believe what we believe for some silly reason. Because they want Star Trek episodes that have time travel in them. They want the science to allow all kinds of nonsense to be real. I just don't. It's so hard to figure out why people are so passionately glued to this crap. It's crap. I can't see it as anything else having looked at it. I mean, you look up the history and it's crap. 1/2 v squared is a crap idea. There was never any evidence. I mean, how many times can I say it over and over again? And then, again, the Deschardelet vis visa controversy in France is so perfect an illustration, because if you look at it, there's just nothing, there's no good science here. And this silly experiment denting clay with round objects, not penetrating the clay, just denting it with a round object as a way of determining how much energy something has. I mean, can't people just look at that and say, oh, that's a gimmick? Yeah, that's not an experiment trying to find the truth. That's an experiment contrived to defend a truth. Because there's so many other better experiments. Just, 10 mass going 5 mass going 10, you tie a string between them and let them go, and you find out that, oh yeah, there's no extra energy in the 5 mass going 10. It doesn't do anything more. It doesn't have any more capacity to move matter. Oh, just, well, anyway, I'm just continually surprised about how difficult this conversation is, and how chicken shit these people are, in the sense that they just keep talking all this abstract gobbledygook. They don't get anywhere close to talking about something that has actually something to do with real atoms, real electrons and protons, which have to be so fundamental to everything. I mean, charge and magnetism, it has to be about electrons and protons. There's no other way to explain those phenomena without just saying electron and proton, dipole. That has to be the explanation. Why would you mess with all this wooey crap? Alright, anyway. So, hit the button and see what happens. So this is number 3 in playing the video. And yes, it's been slow going. I sped up the speed a little bit. We'll see if we can get through this a little quicker. But it's just every sentence is mush, and it needs to be called out for what it is.
One other thing you said that I just wanted to clarify is you said that you don't.
I knew that was going to happen.
You still only have one wave function, and what I wanted to clarify is whether this is the standard reading, that there is only one wave function. I know that that's maintained by those who adhere to the many worlds theory, but do the other interpretations of quantum mechanics also have only one wave function?
Any version of quantum mechanics that is realist about wave functions says there is only one wave function. There's one physical thing, the wave function of the system under consideration, and ultimately the wave function of the universe. There are approaches to quantum mechanics that are not realistic about the wave functions, that are, I shouldn't say realistic, I should say.
Oh, that's really he's really playing a game with the truth there. Obviously, the objects can each have their own wave function in the sense that they have their own environmental circumstance. It would be silly to say that it only exists in this universal context, because the universe isn't entangled with every other particle in the universe. If it is entangled, or it's doing anything to regard, for it to obligate it to have some sort of position. And obviously even gravity sort of obligates it to have a position next to something else, because the gravitational force doesn't care that you're superimposed. You have to have one gravitational relationship with something else. You can't have a gravitational relationship based on the fact that you're over here, or you're over here, or you're over here. You have to be in one place. I mean, so the whole thing is a little bit silly. But this is sort of cheating, where he's going to try to imply that the only way Schrodinger's equation can be applied is in the context of the universe.
So there, you can treat the wave function as a tool that individual agents use to make predictions. And one person might have different information about a system than another, and therefore they might assign a different wave function.
So this is the silly part. So again, we're back to the information thing. In the roulette table, we know that the roulette table is not going to be influenced by somebody 16 blocks away drinking a glass of water. So it's just ridiculous to say that the wave function, the Forky thing, has to include somebody drinking water 16 blocks away, because no, it doesn't.
To the system than the other. But it's not that each individual subset of the universe has its own wave function. It's that each agent has the different wave function they assign to the whole universe all at once.
Okay. And then just so we can tie quantum mechanics and quantum field theory together, you've already said that a field is something that has a value at every location in space, but this doesn't really give a very intuitive conception of what a field might actually be like. So do you have...
So again, this kind of idea only works in the context of establishing the existence of, say, photons coming out of the sun, or gravity pushing us into the earth. You know that at certain locations you can assign a number to how much charge or how much effect you're going to have from whatever the force is. So yeah, we know if I'm 10 feet, or if I'm on the surface of the earth, it's 9.8, and I know if I go 15 miles, it's going to be some other number like 7.4. Depending on how far I go, okay, I'm going to get a different number. But the field is active, and so that's the other argument, is that there's not a static number at any location. It depends on how close the moon is, because the moon's going to change that number.
Have a way of describing a field that makes it seem, I don't know, more physical, for lack of a better word?
There's lots of different ways, and I can give you a couple, but I will also just opine that you should suck it up. That you should really come to terms with the claim that what a field is something that has a value at every point in space-time. That's really what field.
So they keep saying it as if this is some sort of reality, and it's not the reality. There's no number in space saying this is how many photons there are, because at every moment there's a different number of photons, just the truth. And that's, yes, you can draw some conclusions about averages and expectations, but all the sun has to do is have a sunspot, and there the numbers change. So it's much better to understand it's not about some field, it's about some field of something. You have to say the word, field of what? They just keep talking about this field of wheat or this field of corn, and there's no corn and there's no wheat. They just keep talking about some field of a nothing doing a something. That's the bullshit.
Are. Don't let the metaphors or the analogies have too much of a grip on you. Of course, there are many of them. If you go out to the ocean or to a lake and you see waves on the surface, the height of the wave above the average water level is a function of where you are, right? That's a field. It has a different value at every point. In this room, if I go with a thermometer, I could measure the temperature at each point of the air in this room. That's a field. Anything that has a value at every point in space and time is a field.
Yeah, and it's just wrong to say it that way because it's a field of something, and all the somethings you have to define the something, and so we know that there's a difference between moving atoms and moving electrons and moving force. They're all different things. The forces go in the speed of light. The material stuff goes much slower, and there's all kinds of differences between whether you're moving the elements of an atom, the whole atoms, molecules, compounds. All makes a difference.
As I said, towards knitting these two perspectives together, in quantum mechanics, the wave function governs particle configurations. What does it concern in quantum field theory? And do you think it's fair to describe quantum field theory as...
For anyone struggling with ear ringing...
Oh, that's disappointing. Ugh, it's just, So you can cure the ringing in your ears by not drinking water.
To quantum mechanics, or you just subsume it under quantum mechanics?
Quantum field theory is a kind of quantum mechanics. It is quantum mechanics applied to fields rather than to particles. So in both cases, there's a wave function because it's both quantum mechanics. In the case of particle mechanics, the wave function can be thought of as a function of where you might see the particles, right? Psi of x1, x2, etc. If you have a field, let's call it phi, a different Greek letter, phi of x, okay? Then it will have a wave function, but that wave function is now a function of every possible profile that field might have throughout space.
Whatever all that means. So there's no, like I said, they can't really show you a diagram of this schematic of this whatever it is working. Actually creating charge or creating magnetism or creating anything. So it doesn't mean anything. It's just another silly way of drawing something they don't understand. So again, they can draw the inverse square law. You can do it lots of different ways. Well, at least two different ways. And so they're just saying, let's just draw the thing causing the effect and, give it some name, field theory. But they have no idea what it is or how it works. Yeah, we know what it does. I mean, we can watch what it does. Okay, that's the easy physics of seeing what it does. Proving something. But that's the side of it though. Is they don't even acknowledge what it does, because this whole mv squared thing is just this idiotic notion that they keep saying things have this magical energy, this living force, and there's no evidence it could do any work. I mean, it never does any work equal to the value of the force they say it has, the energy it has. It can't be transferred.
So think of every possible field profile phi of x, not each value. Sorry, I keep bumping in. I'm getting too excited talking about quantum field theory. Not each value at each x, but all the possible values of the function phi of x, okay? The wave function of that field will assign a number to every possible function phi of x. And you can imagine in your mind that somehow you were able to observe that field all at once, everywhere, throughout all of space. And then the wave function of that field would tell you the probability of getting different measurement outcomes for that measurement.
Do you think it is fair to say that quantum mechanics has a fundamental ontology of particles and quantum field theory has a fundamental ontology of fields where particles can just be thought of as fluctuations in these fields?
I don't even know why he's saying there's particles involved somewhere where they call it a wave equation, and they don't think an electron is a particle. So I don't even, they use these words, and you're just saying, you don't take any account for what you're saying. Is it a mass moving a velocity or not? That's all that there is. There's either a mass moving a velocity or else there's just goop, okay, being transferred from one place to another. An amount of goop.
I do not, because the fundamental ontology in both cases is the wave function. And the wave function is a vector in Hilbert space in an abstract way that John von Neumann explained to us in the 1930s.
Oh, fuck. That's just so... Oh, shit. Explain to us, but draw me a picture. Show me.
Again, quantum field theory is not different from quantum mechanics. It's just, let me back up a little bit and be more clear. When we teach quantum mechanics to our students when they're undergraduate.
So the really important questions, right? I could just sit there and say, here's an important issue in physics. Does a magnet create any more energy? That is, does it radiate anything that doesn't go into it? I mean, that's a fundamental question, right? So is the argument that what the magnet's doing is somehow creating a force, or is the magnet just excreting exactly what went in, just in a different pattern? And that's what makes it a magnet, is that the same stuff is leaving, it's just leaving with a different pattern. Those are the questions they should be trying to answer. And as soon as they try to answer them, they'll figure out, yeah, it's not making new energy. It can only convert what goes in into something, and that it has to be the same amount of it coming out. And it's just that because the other things in the environment can see the different pattern, that they react to it.
Of course, they've heard about classical mechanics already, right? They know about balls rolling down hills and inclined planes and things like that. They know about
So they don't know about any of that stuff, because they all think it's much more energy in there than there is. They think dropping 2 seconds in gravity gives you 4 units of energy.
Newton's laws and Kepler's laws. And so, of course, also because it went that way historically, it makes sense that we teach them quantum mechanics by starting with classical mechanics. And indeed, even very grown-up, very highly accomplished physicists will construct new quantum mechanical theories by starting with a classical theory and doing what we call quantizing it. There's a set of rules for going from a classical theory to a quantum theory.
It just doesn't make any sense to have this distinction. It's all the physical mechanics, and it's either is something doing something, or it's a nothing doing something. But they should be able to say, that's the ground I'm standing on. I believe in nothings that do something, or I believe in some things that do something.
But that whole procedure is a bit of a fudge, to be honest. Nature doesn't do that. Nature does not start with a classical theory and then quantize it. Indeed, the whole idea of quantization is much less well-defined than you might hope. There's no unique...
So again, it should be something pretty well-defined in the sense that basically you found out that the smallest element is this piece of a photon. That's where the whole quantized word came from. Energy quanta, light quanta. I mean, that's where it came from. So, I mean, the idea that there's this Planck amount of stuff and there's nothing smaller. I can't cut it. I can't divide it. I can't make a smaller unit of it. Oh, shit. And then they took things that were pretty clearly only in these integer clumps like charge, and then started to make things with half charges and quarter charges and third charges, quarks.
Unique map from classical theories to quantum theories. One classical theory could give you many different quantum theories. The map is not well defined. There could be different classical theories that give you the same quantum theory. There could be quantum theories that have no classical precursor whatsoever. So there's even classical theory.
I don't even know what that all that much is. There's probably the whole idea of classical is to say that it was well established and this everybody believes and it is part of your foundation. That's the whole point of saying it. So if you're going to say classical physics isn't physics, then why even talk about it? If there were wrong answers, it's like saying classical religion is the foundation of Darwinian theory, and no, it isn't. It's a menace to the theory. So, in a sense, classical mechanics should be a menace to your quantum mechanics. It's not some sort of elemental to it. That would be nonsense.
That have no quantum theory associated with them. So it's just two different sets of things. And that's why, even though when we talk about particle quantum mechanics and field theory, it's tempting to think that this is a quantum theory of particles or of fields, and we're just describing it in a certain way. It's ultimately wrong to think of it that way. It's a quantum theory of quantum theory. That's what it is. And the quantum ontology is that of a vector in Hilbert.
Oh, brother, a vector in Hilbert space. Whatever the fuck that could possibly mean. I guess the Hilbert space is the four-dimensional nonsense. So, and space is relative, it isn't absolute, and distance is relative, and it isn't absolute. All that mush. And again, it doesn't get to the basic point that all of that nonsense about space was broken by Einstein, and clearly Einstein's bent space can be understood to be creating free energy in the universe constantly heating. Every single object in space is being heated by gravity, and they have no account for that process. They're not even acknowledging the existence of the process. Even though they know the Earth is molten in the center, and there's only one way it got molten, and that's gravity.
Space. And that's how nature thinks, and we should try our best to measure up to that.
Okay, so the fundamental ontology of quantum field theory is the wave function. And I'm wondering then, to get a better understanding of the structural realism position that you endorsed, how successor theories to the standard particle model might have us revise or retain this ontology. And before we get into
Oh, fuck. I must have jumped through this when I watched it. I can't imagine I would have watched this crap. Oh, this is really tedious.
that, since we haven't talked about the standard particle model and that, or the standard model of particle physics, and that's another huge part of quanta and fields, just what is the standard model?
Good. The standard model is a terrible name for the most important theory in all of physics, and it is not a beautiful theory in a very deep way.
They call it a theory. There's no theory here. There's whatever it is, 14 basic particles, and then 464 subdivision of particle. There's no theory. There's nothing. There's a gluon. Oh yeah, it's this particle, and it shoots its tongue out and sticks to a proton, and it pulls the proton in. What the fuck? It's not a theory. Why do they call the standard model a theory? There's no theory. I can't believe they call it. It's not a theory. There's no theorying in the standard model. It doesn't say anything. There's no drawing of how the fuck it does a goddamn thing or how it works at all. Alright, let's hear the explanation of how this is the most important and greatest theories in mankind's history.
When Einstein invented general relativity, not only was it the work of one person, 10 years of really intense work, but the result is just so simple and beautiful. And it's
so nothing. It's just this proclamation that somehow nothing is absolutely doing anything. So there can't be any absolute particles. There can't be any absolute forces. There can't be any absolute anything. So it doesn't make any sense at all. And this theory of equivalence, based on some notion of what we feel. Again, we don't feel gravity because gravity moves every single piece of you, so you don't feel it pushing you because every piece of you is pushed evenly. And obviously, When an elevator pushes you, it's pushing your feet first. There's a gigantic difference. It's not pushing your elemental bits. It's not a little tiny discrete force. It's a big surface pushing on your electrons. So there's no equivalence. Shit.
It's a pleasure to teach general relativity and to think about it, etc. The Standard Model is a mess. It came about over many decades.
Right. So it's this perfect thing, this greatest achievement of mankind, but it's a mess. So that makes a lot of sense.
Work from many different people, involves many different ingredients. The fundamental idea is that, back in the 1920s or whatever, or earlier, we might have thought that particles and fields are two different kinds of things. We knew about the electromagnetic field.
Oh, brother. So, just to have to go all the way back and say, obviously, the fields are always made of stuff moving the speed of light, and it's terribly discrete. We can't put any of it in a bottle, so to speak. And, the matter is this clumpy, big stuff. Oh, shit. That doesn't go the speed of light.
Maxwell and his friends had put together electromagnetism quite successfully in the 19th century.
So they didn't put it together. They didn't come up with, he didn't have any complete theory of anything. Again, they're just simple observations about causes and effects. I mean, come on. It's the force is perpendicular to the, the force in the wire. The field effect is a perpendicular force. I mean, those are things you can observe, and then you can draw some conclusions about why. But there's just no point in saying that somehow figuring out that it's perpendicular has now explained it all. When it's explained nothing.
We knew about particles. We knew about electrons and protons and neutrons, etc. And so they were thought of.
Again, they know about neutrons when they have no explanation. Again, the whole, this did occur to me when I was a kid. I mean, I did actually, in science class, think to myself, why would a neutral thing be in the atom? I mean, what's keeping a neutral thing from hanging around? If I'm neutral, and it can't attract me and it can't repel me, why am I hanging out with you assholes? There's some reason a neutron would hang out in a nucleus? No, there's no reason.
There's two different kinds of things. But when you went to look at what happened, there were very important experimental results like radioactivity. Okay, radioactivity is an example where...
Right. So he brings up something that completely abolishes, destroys, annihilates all of their bullshit theory, because it's showing you that no, it all has a position, and yes, it's all flying in straight lines, and blah, blah, blah. I mean, it's got every bit of indication that it's a push-averse. If nothing says push-averse more than, something exploding and all the pieces flying away. Yeah, that's pretty much telling you the story.
Particles change into each other.
So that doesn't happen. Nothing's changing into each other, so that's all bullshit. You didn't observe that.
In a purely particle-based theory, is hard to make sense of. Like, where did the electron go if it turns into another particle, right?
Right. So we knew that. So look, even in the classical, even in the ancient, 50-year ago, 60-year ago description of physics, electrons were indestructible. You didn't make and break electrons. So this is just woo they made up in the last decade or so, that somehow electrons are popping in and out of existence. So that's just absolute bullshit. And that's part of the Standard Model. Bullshit. The Standard Model doesn't have anything to do with fucking electrons turning into something. That's just bullshit. That's stuff they made up yesterday.
Of course, it went into other particles, but it's hard mathematically to describe that. And when people like Enrico Fermi came along and tried to describe the decay of the neutron into a proton, an electron, and an antineutrino.
So, yeah, the useless antineutrino, right? Neutrinos are useless. They're pointless to talk about. Antineutrinos, yeah, that's like double, triple. I mean, that's insanely useless. That's the Holy Ghost nephew, Jimmy. The Holy Ghost nephew Jimmy. Does the religion really need the Holy Ghost nephew Jimmy? No, it really doesn't need it. Okay, that is just a useless piece of nothing. All right. And the electron and the proton, yeah, that's God and Jesus, for fuck's sake. So why are you messing with that shit? But he just admitted it. The neutron is an electron and a proton. So it's just so obvious. Okay. Well, if the neutron is an electron and a proton, then it's really easy to understand how nucleuses are held together, because the protons are really attracted to those electron things. So that's what's making it all stick together. And there ends up being, twice as many protons as there are electrons in the nucleus. And so the nucleus is net positive. But it's only net positive. It isn't entirely positive. It's just net positive.
He basically said we should think of these particles as excitations in fields also.
Oh, and so again, they're not particles. They're some sort of wobbly bit in a piece of space. Little, wooicles wobbling, little worms, little jellyfish. Little jellyfishing. Oh, fuck. God, I hate this planet.
So the first step was to unify particles and fields into just fields. Now, there are two different kinds of fields, as it turns out, one of which ends up looking like particles, and the other one ends up looking like fields. The particle one are called fermions, after Fermi.
So again, they're calling the particles field. So can it get any more nonsensical that the particles are now a field? The fields are what we're supposed to be moving the particles. And now the fields are the particles. Shit.
The field-like ones are called bosons, after Bose, an Indian physicist who corresponded with Einstein. And these two different kinds of particles are absolutely central to physics today. Most of what we think of as matter is fermionic particles, like taking up space, electrons, quarks, neutrinos. Most of what we think of as forces.
So again, he didn't say electrons and protons. So somehow we know electrons and protons are creating this perfectly equality circumstance of charge. There's no way, and yet they're going to say that the electron is this thing and the proton is this weird other thing full of quarks and blah, 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 and all kinds of the bullshit. And yet somehow they produce a perfectly equal plus and minus, a perfect dipole. And yet they're completely different in structure and composition. I mean, how can that possibly make sense to you people? We know their charge density is exactly the same, so that means their profile in space has to be exactly the same. There's no way they can be of different spatial dimensions. They have to have the same spatial dimensions, because it's like recognizing just the fact that if you're going to have two planets and you're going to have an equal gravity between them, the two planets would have to have an equal gravitational pull.
Come from bosons. They can pile on top of each other. So they give us light for photons or gravity for gravitons, etc. And
they can pile on top of each other. So they can exist in the same space, is what he just said. Do you think they really have any evidence that they can exist in the same space? No.
Amazingly, all of these forces that we know about are related to symmetries in some deep way. I'm going to try to give you the shortest...
So this symmetry, we're just, it ought to be banned. Like it's somehow, they're related to symmetries. I just pointed out how you have the symmetry is in the existence of charge. It's a perfectly symmetrical, polar system, and you're claiming that the elements created have no symmetry.
Possible thing here, because we can go into it in more detail later. But this was a discovery, again, our paradigmatic force theory that we thought we understood was electromagnetism, going back to Maxwell.
So again, we know they don't understand anything about how a magnet works or anything about how charges work, why electrons repel, how they repel. They don't know any of that. So again, they talk as if they have some theory that has shed light on how the damn thing works, and they have nothing. They can't draw it.
And that theory has a deep symmetry in it called gauge invariance. And people knew about it. They didn't know whether it was important or not. So in the 1950s, Yang and Mills, two physicists, suggested generalizing the...
So again, all of this is just made up by whatever this is 4 dozen people, and they all get to decide where all the rest of you kooks are going to believe. And you're falling for that. I mean, it's pathetic.
gauge invariant symmetry of Maxwell's equations to bigger kinds of symmetries. And it made predictions that were obviously untrue. So no one really knew what to do with this. Like mathematically really, really interesting and compelling, but clearly ruled out by the data. So over the next couple decades, people figured out how to tweak the theories so that those theories that Yang and Mills invented are in fact very compatible with.
I mean, it's just pathetic, right? So they re-engineered it to fit the evidence. And does it really do anything? Is there any way you can construct this magical hobgoblinness? I mean, that's all this is. It's some sort of theory of hobgoblinness.
The data. And it turned out to be very, very difficult because there's the weak interactions and the strong interactions. Electromagnetism descends from a higher energy version of the weak interactions.
Right, says you. So again, they don't even understand gravity as a force. I've explained over and over now for the last, 10 days since I realized how obviously flawed bent space is as a theory, that it's clearly non-energy conservational. It's literally it's not perpetual motion. It's a free energy mechanism by their very definition. There's absolutely no explanation for how the heat, the molten center of the Earth, how that energy gets converted into bent space. Nothing. Not even a clue how that could possibly be possible.
They all act differently for very different reasons. Gravity doesn't fit in. There's still plenty of things we don't understand, but we do.
So this is his explanation of how this is the greatest model, and boy, we'd be really life would be so sucky if we had to live without this great fucking model. It's so spectacular. It's made all of our lives so fucking wonderful. Oh, brother.
You have a predictive model for how all of these known particles and forces behave. We have
what a lie. So again, there's nothing. There's no definite. There's fake prediction. You have this predictive model that can predict absolutely nothing.
Fermions, which are electrons, muons, taus, plus their neutrino cousins. And then we have the quarks. We have 6 quarks, up, down, charmed, strange, top, bottom. And then we have the forces, electromagnetism, weak, strong, gravity. And they all play together. There's the Higgs field.
There's nothing. They all play together. They can't draw me a single picture. They can't illustrate this play yard. There's nothing. There's just this silly notion that somehow, because we've invented all this nonsense, that somehow this produces a magnet. And nothing. There's no explanation for how it does that. How this mush creates anything. How it does anything, and even chemistry. Chemistry has gotten so rudimentary in the sense of understanding the whole idea that there's an electron pressure that every atom has, and that when you're combining atoms, what you really have to do is get over that initial resistance that it has and push them into each other. You have to use energy, and that you can extract energy from atoms by breaking them into their elemental pieces. And that doesn't have any of this crap in it. Oh, fuck. It's so easy to understand that the proton, the net positive nucleus has the capacity to capture orbitals, capture things that will be stuck in a relationship to it. Now, I'm arguing that none of it's circling and swirling, that it's all just magnetic. That it's positions in space, and that's all there is. And you could build atoms out of north and south side magnets, and if you don't allow the magnets to flip, you can put magnets in all kinds of positions, and they'll be attracted and repelled at the same time in an equal balance. You can float magnets in positions if you had the power to prevent them from flipping.
Changing the properties that the other particles have. So it's very intricate, very ugly, and exquisitely adapted to fitting all of the experimental data that we have.
I know. It's just amazing. All the experimental data we have. What experimental data is this? It's all just accelerator mush. There's no real anything here. There's no real data. And again, they've never even dropped 4 pounds 1 foot and 1 pound 4 feet and proved that the 1 pound dropped 4 feet is the same energy. 1 pound going twice the speed is the same energy as 4 pounds going 1 unit of velocity. Never proved that to be true.
Know that this is exceedingly basic for you and repetitive, but on a very superficial level, everything you just said about the standard model seems to suggest that it is about fields and particles, or forces which are also cashed out in terms of fields and particles that come out of them. And hence that, again, facially, these are the fundamental objects of the theory. So can we just make explicit again?
So we know all of the great advances in molecular theory, biology, was all out of understanding electrons and protons and nothing else. So how is this bullshit have anything to do with anything useful? I mean, it didn't really advance anyone anywhere. It hasn't made anything. It hasn't facilitated any good science. All this other crap.
Why this is the wrong way of viewing the standard model, and that it is the wave function that is the fundamental ontology of the theory.
You're such a philosopher, Robinson. You're never gonna escape this way of thinking about things. It's not wrong to talk about either particles or fields, and I make that point in the book. If the question you ask very precisely is what is the fundamental ontology, then
there's force and matter, so they've got it also particles and fields. No, it's force and matter. Matter doesn't do anything until a force creates motion in the matter. There's no such thing as matter having its own properties of motion. Forces have to cause it to move. And forces can't do anything until they interact with matter. Forces can't act on forces. They can't do anything to each other. They can only make something happen when they hit a piece of matter. I mean, it's just so obvious.
Answer is the wave function, the quantum state, a vector in Hilbert space. But if you ask
again, the vector in Hilbert space. Jesus Christ. So let's understand Hilbert space is also this MV squared space.
a different question, which is how do we best understand what's going on? What is the most convenient and useful and informative way to talk about what's going on? Then clearly it's fields and their excitations, the particles. That's okay.
Fields and their excitation, the particles. So again, they're saying an electron isn't a thing. It isn't a discrete, definable object of consistent properties that lasts forever in the universe and is just recycled into different atoms through interactions. That's not what an electron is. It's some sort of field poofy.
The fields and the particles are sort of an emergent way of talking about it, or even a little bit more precisely, they're kind of like coordinates, right? When you have coordinates on a manifold, it's very, very useful to have coordinates. If you want to do general relativity and talk about the precession of Mercury, the first thing you do is choose a coordinate system to work in.
Oh, obviously, as the rational coordinate system would be three-dimensional space because there's nothing else. That's not so fucking obvious. So again, they think that space is being poofed, into existence at a constant rate or some kind of a non-constant rate. Somehow it accelerates and decelerates the amount of poofing space. I mean, the whole thing is just such a pile of crap.
But that's not fundamentally what matters, right? It's just a certain choice that human beings make to make their lives easier. Same thing is...
Again, what does this have to do with human beings? This is about a tiny number of people who are inventing a religion that apparently people feel like bowing to it and revering it, even though it doesn't do anything.
True with the fields of the standard model. They are a super duper very useful way of talking about this quantum theory that is fundamentally defined by a wave function obeying some equivalent to the Schrödinger equation.
When people hear
some equivalent, it's just amazing. Some equivalent. Oh, shit. Nothing is real. Everything is this mushable, erasable goop.
from people like me who repeat this over and over again, that the standard model has been confirmed to something like 14 decimal points.
Okay, so again, this is the big lie, right? The 14 decimal point bullshit just has to do with this silly magnetron device where they know exactly what it's doing, and so they just sit there and predict what the machine they built to do a certain thing does. I mean, it's ridiculous. It's so silly. I don't even know what to make the comparison. They're measuring the length of a pendulum, and then they know what the rules are of pendulums, and they're just sitting here and refining it by let's choose a string that doesn't stretch at all, and let's do this, and let's take the air out, and let's do, and they're just refining that and saying, look at how many decimal points we're predicting the truth, and it's nothing. It's absolutely nothing. They're predicting nothing they don't already know.
And as you've said, it's our best empirically confirmed theory.
I just empirically confirmed by nothing. Oh, fuck. And again, they haven't dropped 4 pounds 1 foot and 1 pound 4 feet. They haven't done any experiments. They haven't crashed a car. They haven't done anything to tease this truth out of the physical world.
Exactly does this mean?
On the job site, leaders aren't born.
All right, let's see if we can get through this.
You can't quite say, I would like to be able to say, but you can't quite, that the standard model is confirmed to like 14 decimal places. Parts of it are. In fact, mostly the parts that are electromagnetism. That's the one that we understand the best. But the weak and strong nuclear forces are confirmed to a few decimal places, but maybe not.
I mean, it's just so ridiculous. They haven't confirmed any of this stuff. This is all just hyperbole. They're just way exaggerating anything that could be defined as a proof of anything.
To 14. What it means is, for the most part, and this is not the whole story, but this is the most important part of the story, we scatter particles off of each other.
There you go. So that's the definition. So let's just understand. They scatter particles, and then they interpret what the results are saying. They tell you that what it means is there's a freaking quark in there, and it did it, an up quark, and then the strange quark did this, and the down quark did that. It's just such bullshit.
Collide particles together, and we see what comes out. This is the paradigmatic thing that you're taught to do when you take your quantum field theory class.
Oh, bullshit. And then what they do is take the velocities of these particles that they create and way exaggerate the energy because they're using the stupid mv squared. So they end up creating this thing that they say has all of this insane amount of energy, and then they say, well, how could that much energy be created? There must be a whole bunch of stuff that happened that created that much energy, when it never happened. There wasn't anything creating all that energy because the energy isn't real.
You imagine setting up an initial configuration where two particles are coming in to hit each other. They hit, they convert, because they're really waves in a field, and those waves...
Okay. So again, this is all bullshit. I'm sorry. Just all bullshit. The particles usually never hit each other. They hit each other's forces, so to speak. So, the forces surrounding them. And so, you can bang a proton into an electron, but you're not going to bang an electron into an electron. Not going to happen.
Waves are going to set up vibrations in other waves, so they go out as other kinds of particles. And there's a mathematical description.
So again, they don't go off as anything other than what they are. And because they're going some other velocity, they've decided it must be some other particle. So again, the positron behaves exactly like the proton. And they're just claiming because it's going a certain speed, it must be a positron and not a proton.
For what happens using Feynman diagrams. And Feynman diagrams are this beautiful way of calculating the probability. Given some initial state coming in, what is the probability of observing different states going out?
I don't think that's what a Feynman diagram does, but fine.
So either metaphorically or literally, that's what we do. At a place like the Large Hadron Collider in Geneva, we literally do that. We collide particles together. We predict what's going to happen using Feynman diagrams.
Right, so you put a million things in, and stuff comes out. And they draw conclusions on what individual things are doing based on what possible circumstantial bullshit you can create. So 1 in 1,000,000 times they get some sort of thing that happens, and they say, well, that's an aberration, and therefore we have to give it a name and call it some new invented thing, even though it never really happens.
We see what comes out and we compare that to the predictions. That's where we get to say the standard model is so enormously successful.
All right, so again, we understand their test is this obtuse, invisible, mushy dissection that really doesn't have anything to do with anything like a microscope or a telescope. It doesn't have anything to do with really getting a good picture of anything. It's just some abstraction.
You also, in the book, you mentioned that, it has some serious weaknesses. And I'm getting toward, after we talk about this, what comes after the standard model. But what are some of the weaknesses that it has despite being so well confirmed?
Well, I think that there are...
Again, I hate this, so well confirmed by nothing they're going to show us ever. We're never going to see this fucking evidence of this fucking conclusion drawn. All right? It's nowhere. You can't find it on the internet. You're not going to find any evidence of this crap, how they deduced this crap from whatever data they were collecting. We're never going to see any of that.
Are two kinds of weaknesses in the standard model. And, let's be fair. Let me be super duper fair. 3 kinds of weaknesses in the standard model of particle physics. Okay. One is that gravity is not complete yet. We have a theory of gravity, general relativity, that is very, very good.
So there's no theory of gravity. Just understand it's a nothing doing a something. Okay, that's not a theory of gravity. Nothing does something. That's not a theory of gravity. That's not a theory of anything physical. That's not a theory worth even talking about. That's a hobgoblin. That's shit. Okay, so until you tell me what physically happens, as Newton says, until you tell me, if you're going to sit there and tell me that some woo happens and the woo makes the thing happen, you're just wasting my time. There has to be some kind of mechanism. There's no mechanism for bent space. They can't even draw it coherently in 3 dimensions. Besides just drawing what you would be drawing a vacuum cleaner. Put a vacuum cleaner hose in the middle of the earth, okay, and then start sucking the universe in. That's it. There's nothing. It's just complete bullshit.
But, and there's even a quantum theory of gravity, which works, here in the solar system. As long as gravity is not that strong, we have quantum gravity, no problem. But we don't have a complete...
There's no... Well, show me. What is this quantum gravity? Show me something that has a mechanism. Show me something that has something to do with the something causing the something. How can I have a something cause, something happens, and nothing made it happen? Shit.
Finished, final theory of quantum gravity, so we don't completely understand black holes or the Big Bang or things like that. Now, usually physicists deal with this just by not including quantum gravity in the standard model of particle physics. Frank Wilczek has advocated for grouping them together and calling them, did I say quantum field theory? Not including gravity in the standard model of particle physics. Frank Wilczek says we should call them the core theory as sort of a version of the standard model that does include gravity. But still, you would like to understand gravity better than you do. The second problem is that
there's no way to understand it. Okay, it's just saying there's an inverse square law force. And we don't have to account for why it exists, why it happens. Things just magically get momentum. They move towards the center of the Earth. They apply a constant pressure as mass. So as soon as they hit the surface of the Earth, they're still trying to get to the center. And it creates a whole bunch of heat, a whole bunch of radiant energy is excreted from the Earth, and we don't account for any of it. We don't even explain how that energy gets converted back into the bent nothing. It's just such crap.
Is empirically something very, very big that was not part of the standard model, namely dark matter in the universe.
So again, the whole conversation about dark matter. Oh, our math doesn't work. We're not getting the right answer. Therefore, let's just create invisible fake stuff that creates gravity but doesn't do anything else and call it dark matter when it could be just dark hobgoblins. Fuck. I can't believe I have to spend time on this stupid planet fucking arguing with this crap. Absolute steaming crap as a theory. Made up shit. Fuck.
So, and maybe there's other hints from like astrophysics and whatever that the standard model is not quite up to the task of explaining observational data from astronomy, right?
It doesn't explain anything. It doesn't explain anything. I mean, no biologist, no chemist ever sits there and says, well, then the Higgs field caused the two atoms to... No. They never do this.
It explains very well observational data from laboratories here on Earth, but out there in the universe, it's a slightly different story. So almost everyone believes, although we're not 100% sure, that you need to go beyond the standard model to account for dark matter in the universe. That's the second problem.
Oh, fuck. So they're so sure that dark matter exists, and yet it's just silly made-up shit to account for their miscalculation. The fact that they don't understand that galaxies aren't solar systems. Galaxies, unlike solar systems, have mass on both sides. So yes, there's an Earth over here. Yes, there's actually an Earth on the other side. And so technically, you wouldn't need the sun for them to orbit each other. They could do it all by themselves without there being anything in the middle. Oh, fuck. Amazing. And they have so many examples of binary systems where they know something's actually binary. They know some like a neutron star, different things that are turning, and the quasars, whatever, whatever the ones that are blinking. They know it's a binary system. They know this idea of a binary system is a real thing, and yet they can't figure out that maybe that's what the real energy of a galaxy is. Oh, shit.
The third problem is, even though...
I mean, you have all this mass in the arms of the galaxies. You can just see it sitting there. You're saying, I'm not going to count that. That's not part of the gravitational equation, all that mass. I mean, it's ridiculous.
The theory fits the data. It does so at the cost of a weird set of fine-tunings that we don't understand. By which I mean... the standard model has all these different...
I mean, a wheel turns and the little things on the outside have to go really, really fast. They have an obligation to. They don't go slower, they go faster. Because they're stuck. And the stuff in the gravity, okay, in the arms of a galaxy, they're stuck. They don't have a choice but to move faster because they're in a big blob of matter. And the whole blob of matter has to bend or go slower for them to not go faster. So I mean, they don't even get it. There's a ton of mass in the galaxy that isn't in the fucking center. It's not a sun-centered system.
Fields in it, and these fields interact with each other in different ways, and those interactions are generally parameterized by some coupling constants. And most of the coupling constants are very well behaved. They're, like the fine structure constant of electromagnetism is approximately 10 to the minus 2. It's, slightly small number, but it's not crazy or anything like that. But then there's these other numbers, like the ratio of the mass of the Higgs boson to the Planck scale of quantum gravity. That's 10 to the minus 16. That's a weirdly small number. And the ratio...
And we're supposed to believe this is a real thing. Whatever this Higgs field is somehow giving matter its capacity to bend space. I mean, it just doesn't even make any sense. The matter can't bend space without the Higgs fields somehow. The whole thing is just so fucking silly.
Of the vacuum energy, the energy in empty space, to the Planck's...
Okay, so the vacuum energy is a good idea in the sense of just recognizing that space is full of goddamn fucking energy. It's full of little bits of shit moving around all the time. And that is the pressure pushing everything into each other. Duh, that's the gravity.
Scale to the fourth power is 10 to the minus 120 and something. That's a crazily small number. And we don't know why.
So all of this nonsense about who cares about these silly fucking calculated nonsense numbers that don't have anything to do with anything that actually functions. So again, it's just bullshit. They're just doing it to prove they can calculate numbers, not doing it to prove it means anything.
there's other small numbers, like there's a parameter in the strong interactions that governs violations of a symmetry called CP. You've probably never heard of any of this, but there's a number that should be between 0 and pi, and we measure it and it's less than 10 to the minus 10, and nobody knows why. So there's these weird features of the standard model that in order to fit the data, you have to take numbers that you would have guessed would have been 1, 10 to the minus 1, 10 to the minus 2, and set them to much, much smaller values. Those kind of fine-tuning problems hint to most of us that there is physics beyond the standard model that helps us make sense of these problems, but we don't know what it is yet.
Oh, God, it's just, so it's nothing's going beyond, it's going much below. They need to go way back to Newton, okay, and start making rational deductions rather than this wooey speculation about bullshit magical forces, magical mechanisms.
Yeah, just to see if I can categorize these maybe two types of weaknesses, would it be fair to say, and again, totally shoot me down when and if I'm wrong, that something like dark matter could be fit into the standard model without having to totally revise it or find deeper physics, whereas the
Dentist.
All right, so there's almost no point, right? So I guess we're at the hour, so we'll pause there. What did he just say? Yeah, dark. So this whole idea that somehow they're going to worry about, they're created this artificial matter that somehow doesn't in any way interact like matter. It's not even, they're not even calling it antimatter. They're calling it some other kind of matter that doesn't do anything but make gravity, but you can't bounce anything off of it. I mean, it's so ridiculous. You can't give it momentum. You can't do anything. How the fuck does it even function in the universe? How does it end up where it is if it can't be moved? I mean, the whole thing doesn't make any sense at all. It's such a pile of shit. Fuck. All right. So. Yeah. All right. So I don't know whether it's worth making the rest. I look, I might as well, right? It's your time, my time. Doesn't make much difference. I mean, it's not going to kill me. To play it through, but yeah, there's no real physics in any of this. This doesn't have anything to do with the key reality of motion in the universe and how objects acquire it and excrete it. Energy and force. Energy, force, matter. That's all you're supposed to be talking about, not all this other crap. Alright. Till the next time and such. But shit. Why do people believe this crap? I mean, it just stuns me that you listen to this shit and say, I'm convinced because he said so. We tested it. You're sure you did. You can't, they haven't tested the simplest things and you're trusting them. They haven't done the Eddington experiment from space. There's 400 times better resolution. The experiment's 400 times easier to do. And they haven't even attempted it. And you think that's good science? Then fuck you.